We are excited to provide a solution of the cloud architecture we have designed and deployed for any group LLC. The presentation will be delivered by Cheng Li, Yuhan Zhao, Xinyi Ding, and Zhiwei Xu. An overview of the cloud architecture. The VPC isolated infrastructure with two public subnets hosting web servers and a net gateway, and four private subnets for backend servers and Amazon RDS instances, ensuring security and redundancy across two AZs. Row tables managing public and private traffic, using Internet Gateway for web access and Net Gateway for secure outbound traffic from private subnets. NACLs, ensuring security by allowing HTTP and HTTPS traffic to the web tier and MySQL traffic between application and database tiers. The application load balancer distributes traffic across EC2 instances in multiple AZs for high availability. Auto-scaling groups dynamically adjust EC2 instances based on demand, scaling up during traffic spikes and scaling down during low traffic, ensuring operational performance and cost efficiency. Amazon RDS use multi-AZ deployment for high availability with automatic failover between AZs. Backup are stored in Amazon S3, offering a cost-effective disaster recovery with 7-day retention period, ensuring data durability and security. Amazon Row 53 handles DNS, routing traffic efficiency to the ALB. CloudWatch alarms monitor critical metrics like CPU utilization, triggering notifications via Amazon SNS to ensure engineers can address issues promptly, maintaining system reliability and uptime.
My main job in this project is to deploy VPC subnet roundtable NACL Internet Gateway and Net Gateway. When setting up the VPC and the subnets were configured using AWS setting with the AZ2 public subnet and full private subnet configured according to the requirements. In the row table, two row tables were used to divide the public and private subnet into a public roundtable and a private roundtable. The Internet Gateway was used in the public roundtable to link the VPC to the Internet. In the private roundtable, a net gateway was used to provide connected between the public and the private subnet. The Internet Gateway was set up by AWS when configuring the VPC and was bound to the public roundtable. The Net Gateway in public subnet 1 linked the public and the private subnet. In the wet NACL, the default setting was used. In the application tier NACL, the inbound rule along HTTP and HTTPS traffic from the public subnet, and MySQL traffic from the private subnets 3 and 4. This alone requires from the website long and the response from the RDS. This is to ensure that in case of RDS not work, traffic can be quickly switched to the other RDS. In the database tier NACL, the inbound row and along traffic from the provide subnet 1 and 2. And when application line research locate, and in all three NACL, the inbound and outbound rows are configured.
This is Yuhan Zhao, and I will show the EC2 instance configuration and the load balancer and auto-scaling group setting for our any group LLC. First, I will show the EC2 instance configuration. We already have two instances for web server and app server. We set up earlier, so we already have two instance templates that belong to the web server and app server. So the ANI and instance type setting should be the same as the earlier we set up. This is make it easier to manage everything and lower the chance of mistake. Having multiple instances is super important to handle lots of users and make sure the site keeping running. It can follow the operation excellence pillar of AWS well-architecture framework by keeping things simple and reducing human error. So we put the new instance for web server in another public subnet in the US is 1B, and the inbound role allowing all HTTP and HTTPS traffic from the load balancer. The security group is very important for keep our server secure. This fits the security pillar by making sure only the right people and traffic can get in. The instance of app server is set up the same way as the web server. The instance belongs to the private 2 subnet in the US is 1B. The security group allows all HTTP and HTTPS traffic from the web server. Now we move to load balancer setting. LB is a service that smartly distributes traffic across multiple targets to improve server performance. We're choosing the internal facing type because it handles traffic within the private network. Keeping it on the internet, which reduces the risk of attack and keeping the internal communication secure. The deploy of network mapping is for load balancer across two AZ to ensure the system remains operational even if one available AZ encounter issue. And we set up the security group for the load balancer to allow access from HTTP and HTTPS traffic. This configuration ensures secure and efficient traffic distribution, enhancing the system availability and performance. And for the auto-scaling group, the web auto-scaling group track the number of requests of each instance handled through the ARB. If the request per instance go above 300, it will auto add more instances. If the request drop below 300, it will reduce the number of instances. The App Store as ASG use a target tracking scaling policy to keep the CPU utilization. When the workload increases above 50%, it will auto add more instances. When the workload decreases below 50%, it will reduce the number of instances. It will help keep the system running smoothly while saving costs.
The multi-easy instance deployment of RDS could allow automatic failover to the standby instance when there is a fail in the primary database, enhancing durability and availability. The second instance will replicate the primary RDS. Additionally, the RDS will store the snapshot automatically into S3 bucket to help with disaster recovery. Firstly, we create subnet groups. In a multi-AZ setup, AWS creates a standby database instance in a different AZ. The subnet group defines the subnets in which both the primary and the standby instances will be deployed. Check all the subnets and identify in which subnet RDS instance should reside, which are subnet private 3 and subnet private 4. Add these subnets into the subnet group we want to create. Subnet group created. Then create the RDS. Choose the multi-AZ instance as the deployment option, which means that the primary database and the standby database will be deployed into different AZs. This option does not mean that the database is distributed across multiple instances. Instead, one instance is the primary instance, which handles all the requests. Another instance will be launched as a standby instance, which takes over if the primary instance fails. In the connectivity section, choose the VPC and the subnet group that were created before. The subnet group contains subnets into different AZs, which are USEs 1A and USEs 1B. The RDS will create the primary and standby RDS in these two subnets. After creation, we can see the RDS is created in the correct VPC and subnet group, and the primary instance is in AZ USEs 1B. Additionally, the security group DBSG is associated to this RDS instance. The security group has one allow inbound rule, and the allow port is 3306. It only allows inbound traffic from resources associated with security group application server (SJ), i.e., EC2 instances that are in the server tier. In the configuration section, we can see the multi-AZ is enabled, and the secondary RDS is reside in USEs 1A. Through RDS automatic backup, it stores snapshot in S3 bucket. This backup occurs during a daily 30-minute period as backup window, and the backup are kept for 7 days as a retention period. Although database snapshots serve operationally as full backups, you are built only for incremental storage use, which is cost-effective.
Hello, my name is Zhiwei, and I would like to show you today the AWS Route 53 setup, managing domain names and integration with load balancer, and AWS CloudWatch alarms and the SNS topics. So first, what is Route 53? So it's a DNS server that managed by AWS, and we can set up, as we can see in the AWS console, we're able to navigate to the hosted zone that we have created. It's called manualmaster.com, and in here we have created a record called web.manualmaster.com. So this will allow the users to access via the domain name to the load balancer, which is created previously by one of our teammate. So these are matching, and this follows the architecture framework that ensures easy access for the users, in particular the security pillar that users only able to access to the domain name without going directly to the web tier EC2 instances. So following the web architecture framework, operation excellence, now we look into the AWS CloudWatch, which provides the capabilities of monitoring, set up alarms and notifications, which is what I'd like to touch on briefly. As we can see, these are the EC2 instances that we wanted to monitor, and so this is CloudWatch alarms. So here I created a few alarms that monitors the EC2 instances. So there are cases that we created for the status check. So in case EC2 instances are failing or whatever issue might happen, this alarm will be triggered, and it will notify our engineers on the EC2 instance status. Also, as importantly, we also monitor the CPU utilization. So once it's reached to the 90% threshold, we would also like to notify the engineers. How do we do that? We achieve that by using the SNS topic. So we created a resource alerting topic, and we also create subscriptions, which in our case is using email as a protocol, and we use this email endpoint as this is one of our engineer's email address, and that person would be notified if the alarm was triggered. So that way it helps the operational side of the equation a lot better. So throughout the above demos, we explored Route 53 and how a normal user would visit any group website and how it's interacting with the application. And we've also observed how CloudWatch alarms are set up and monitoring the EC2 instances. In this case, how the CPU utilization was, and also the status check. And then the notification would be triggered. The notification will be triggered once the alarm is activated, and then so that our operation engineers are aware of the issues. Thank you very much.